machine learning with Pytorch and Sklearn. And we are in this chapter, chapter 6, learning best practice for model evaluation and hyperparameter tuning. What we have been seeing is that let's assume you train a model, and now the model performs somehow, and you need to fine-tune the model, select best parameters so that you can train a best model. And that's what we did. One way we discussed, K-fold cross-validation. We discussed yesterday debugging algorithm using learning and validation curves, which basically these are some of the learning curves we discussed, which basically try to let me go. Okay, so this is what we discussed yesterday. We discussed about learning curves, which basically allows you to see how many training data, because even the number of training data you're gonna train your model is hyperparameter, because you don't know like how many should be in training set, how many should be in the test set. All these are hyperparameters. So we discussed this. We also discussed about learning curve, which basically excuse me. We discussed learning curve, which also allow us to do, select that. We also discussed about this, which basically we run our parameters here and the accuracy here. And these parameters are our hyperparameters. And now we can select the best hyperparameter we can tune based on our curve. So these are some of the good thing about thing we have discussed previously. And I also share with you, I think a book in this, I think, do I have the book here? Yeah. So this is something good and will serve as a good reference when you are doing so. This book I shared in it, Machine Learning by Andre Ng. If you are into machine learning, you may know Andre Ng. Andre Ng is one of the leaders, in machine learning, and some of us are doing one of it. Remember, I share with you a machine learning course from Coursera, so it's by Andre Ng. So one good thing I like about this book, it's not like something that you just go and read, and it's just like a kind of what do you call it? A kind of what do I call it? So if you want to do something and you want to just find out the explanation how some stuff works. For example, you want to find out how are you going to divide your data set into train and test set? What is the best approach? So you can see here, this is your dev test, and so you can just come here. How large your dev and test set should be. So you can read about it, and now just 2 pages and stuff like that. You can understand highly what this is. So what I was saying is that what we discussed about bias variance techniques, this learning curves. So it is there. So you can read this learning curve. I read it and it really makes sense. You can understand more about this learning curve and stuff like that. So this is something that you can keep it inside your arsenal, and you can reference it when you want to, do some stuff in machine learning. And it has a lot of good tools and advice on how to you consider. Okay, so you can get the book in the Slack channel. So what are we going to do? So remember, the chapter we are still doing is fine-tuning hyperparameters, selecting best hyperparameters. Now today what we will see is grid search. So what is grid search? If you can see here, we have, if you remember, we have 2 types of parameters in machine learning, right? We have what we call hyperparameters, and we have normal parameter, model parameters. Who can tell us the difference between the hyperparameter and model parameters? And anybody that doesn't know what the difference between the two? Anybody can help us? What these hyperparameters and parameters? We discussed this, I think, in the first chapter of this book. Anybody can chime in? Kwa manta ne hyperparameter and parameters.
Gaskiya ni dai na manta.
Okay. Anybody can remember what is hyperparameters? What is parameters in machine learning? Falalu, can you help us? Okay. So maybe Kua.
I think, Doctor.
Yeah, wow.
Hyperparameters, we use hyperparameters to tune the model. Okay. I mean, these are the features we select in order to tune the model, and the result is parameter.
Okay. So Inaji,
I was just able to remember a little.
Okay. Yeah. So Inaji, when we started this chapter, I made mention, that is why I said, if you don't practice this, if you don't read it yourself, and you easily forget this stuff. So it's very good to practice. There is what is called I don't know if you have idea what is called test repetition.
In another term, we can say that the chosen parameters before training.
Yeah. So So what is hyperparameter? So when you want to do machine learning, a hyperparameter is a parameter that we choose before we train our machine learning model. So what does that mean? So for example, if you are training a decision tree, you can specify how many depth the tree is, maybe level 1, level 2, level 3. You can specify that. That is called hyperparameter. Before you train your machine learning model, you specify some parameter. Even the train test split ratio, because before we train our machine learning, we divide the data set into maybe 80 to be training set, 20% to be tested. That division that we do, 80-20, is hyperparameter, because this is it. And you remember in K nearest neighbor, we provide the K, the number of neighbors we want, maybe 3 neighbors, 4 neighbors. That K, that number is hyperparameter. When we are training deep learning model, we provide epochs, number of epochs. That means how many rounds will it take to train model? Maybe we can say 10 epoch, 20 epoch, 50 epoch. That number of epoch is called hyperparameter. When you are training machine learning model, deep learning model, sometimes you specify the depths of layers. Maybe you are doing 2 layers, 3 layers, 4 layers. Decide depending on what you choose. That kind of selection is called hyperparameter. And what is parameter? Now, parameters are the result after you train your model. If you train your model, what you learn, the weight, for example, in deep learning, the weight are called the parameters. If we train logistic regression, the coefficient we find that fit the model is called parameters. So you should be, you should know the difference between these two things, parameters and hyperparameter, because you may be confused about them. Any question about them? Any question? All right. So I want to share a link in the chat. You can have access to it. What is hyperparameter and parameter tuning and parameter? This is a link. You can read more about it. So let's go back to where we are. So remember, this is it. So hyperparameter, I just iterate them here. These are all hyperparameters because these are number of iteration, test size, random set, maximum of depth. If you are training decision tree, C, gamma in support vector machine, number of fold if you are using cross validation. Remember, if you are using cross validation, we can say we are going to use 10-fold, right? So that 10 and the number of fold is hyperparameter. But parameters, so when we train a machine learning model, y is equal to this weight that we find are called parameters. This is what the model, what the machine learning algorithm learns. So let me show you an example. So let's assume we have something like this. Y is equals to 3x plus 1, right? Okay, so y is equals to 3x plus 1. And what we want is maybe we want to find 5x value for x that basically, oh, let me write something like y is equal to mx plus c, something like this. Or I can write xw, maybe, yeah, plus c, something like this. When we train a machine learning model, remember, this w weight is what we try to find out. So when we train a machine learning model, we find this kind of weight. These weights are called parameters because it is after you train your machine learning model. Parameters are values or some stuff that you find after you finish training model. Hyperparameter are stuff that you give before even you start training your machine learning model. So yeah, so this is it. So let's go on and see what we're gonna do today. Now, that is why we call this chapter is called hyperparameter tuning. If we go back to the chapter, yeah, so this you can see that this is the chapter is called learning best practice for model evaluation and hyperparameter tuning. Meaning, what are some of the hyperparameters that you can select before you train your machine learning algorithm so that you can get best performance? You cannot tune parameters of a model. You can only tune hyperparameters because these are some of the things you select before you train your machine learning model. Parameters are the result you get after you train your model. I don't know if I'm making sense. Does that make sense?
Yes.
Okay. Akwai tambaya? Ko mai tambaya? Okay. So in that case, let's continue. So yeah, so this is an example I also give, parameters and hyperparameters. So you can see estimated during the training with his code. So you get them estimated, you get them while kind of training your model. But one values in the case setting while training your machine learning model. For example, now here I want to train let us see an example. Yes, we train many algorithms, right? So for example, here you want to use cross-validation. And now here we can see we create logistic regression, right? We want to use logistic regression, right? And now we said, okay, but we want to use PCA. So you can see PCA, how many components we want to create? 2. So 2 is a hyperparameter. Now we want to do cross-validation and we want to use tenfold. Then 10 CB cross-validation is hyperparameter. So we divide our training data. So these are just hyperparameters we are setting before we train the model. So it is part of the model, external to the model. So you can see hyperparameter is external to the model. Not part of the train model, but this is part of the train model, depend on the data set. So you can have different parameters. If you change the model, if you change your data set, then you can have different parameters because the model learn parameters from your data set. So this is something that I wanted to recap about parameters and hyperparameter. So what we are trying to do is this chapter is how can we best select hyperparameters? That is called tuning. Tune means to select best one so that you are machine learning. So because, for example, now you want to train your machine learning model and you just select maybe you just select number of component is a number of component. What I just shows. You want to train logistic regression. Okay, now maybe you want to train logistic regression, which is, to do classification. And now you just select penalty L2, maximum iteration 1000. Now, when we select this, we just select them anyhow, and we train the model. If it doesn't work, we just reduce maybe, okay, let me select 100. And now if it doesn't work, let me select 101. Can you see that? So this parameter, we just select them, hyperparameter, and we train the model, and now see if this does work. If it doesn't work, we change. If it doesn't work, we update. Now, how best can you select the best ones? That is called hyperparameter tuning. So you can see in previous, we use validation curve to improve performance model. So in the previous session, we saw validation curve to see how our C differs. But today, what we're going to see is called grid search. Now, what is grid search? before you train any machine learning model, it is important to understand what the parameters mean before you try to adjust them. So you can see this is a very something very good we should know. Before you train any machine learning model, you need to understand the parameters that that machine learning model support. So let me share my this Safari. We can see something. I want to share that. Okay, let me share again. Okay, now maybe we want to do SBM Sklearn. Can you see my browser? Can you see my browser?
Yes.
So maybe we have SBM. You want to train SBM. You know, we have different kind of machine learning algorithms. Now, if you want to train SBM support vector force classification, now, before you train, this is the support vector. Now, it has many parameters. Can you see them? C, kernel degree, gamma, coefficient, shrinking, probability. These are all hyperparameters that you can set before you train support vector classification. These are all hyperparameters. So whatever machine learning algorithm you want to do, make sure that you know what are some of the parameters. You need to know what are some of the parameters. So for example, let's go to perceptron here. Now, if we go to perceptron, so look at perceptron. Can you see some of the parameters? It is not necessarily that you know all the parameters, but you should know the basic parameter that can work with that algorithm. Yeah, so now the problem is we have many parameters, right? How can I choose the best one, which is a difficult task? So find the value for the important parameter of a model is tricky task. Can you see that? But necessary for almost all models and dataset. So you can see finding the best parameters is tricky, but it's necessary because it's such a common task. Scikit-learn comes with something called grid search CV. Now, so let's assume that we want to do train support vector machine grid search. We want to use grid search. Let me show us this. Let's go back. Classification. So here you can see we have many kind of classification, linear, naive bias, ensemble, mass class, support vector. So let's go here. Now, when we come here, SBM, we can see that classification, SBM. So you can see here, this is for classification. We have SBC, we have this, we have linear SBC. When I go to SBC support vector classifier, you can see here, I have many hyperparameters. C, kernel, degree, gamma, coefficient, shrinking. All of them, there is explanation for them here. Can you see the explanation? And it is good, like you can come when you have time to practice some of those stuff, but it's really difficult, many of them. So now how can we select each one? So now let's try to see, so here we can see there is a gamma, there is, you can select kernel, RBF, yeah, so you can see what is C, regularization parameter. So C is a regularization parameter, meaning if your model is overfitting, then you can, use C to basically regularize a model. Kernel, we have different kind of kernel, linear, poly, RBF, sigmoid, specifies the kernel type, which kind of kernel, degree, which kind of degree, gamma, kernel coefficient for RBF, polynomial, there are a lot of stuff. The theory, we are not discussing them here. Now, so let's go here and look at what we're gonna do. Now we're gonna look at what is called grid search CV. Now, grid search CV is basically, it's used what is called, what do you call it? Exhaustive search to find the best parameter. So for example, now, if I want to train a model. Here you can see, for example, I bring, no, here, not this example. Okay, let me go back. So I want to train a model, right? I'm using SB, support vector classifier, but the support vector classifier, it has different kind of C, which is regularization parameter. Now the regularization parameter, I can test with this, I can test with this, I can test with this, I can test. So I can provide different kind of C, value of C that I want to use. I can also provide different kind of value of gamma that I want to try my model here. Now, what you need to do first is you need to create a kind of dictionary. So we know dictionary, yeah, we know dictionary. So if you look at this one, it's a dictionary. So for example, now here you can see what are you going to try to, you're going to do grid search is C, parameter C. Now, okay, I want to my machine learning algorithm to try this value. Idan ya gama, let him try this one. If it finished, let him try this one. If it finished, let him try this one. So maybe instead for me to run machine learning algorithm with only one value, after I finish, it takes 1 hour or it takes 5 minutes. I see that the result is not good. I now select this one. I see the result is not good. I now try this one. No, can we give the machine learning algorithm a range of values so that he can select the best one among those values? That is the idea. So you can see, since I said SBC, it has like a C. Can you see that? And now it has another value called gamma. You can see gamma. Can you see gamma? So I want to try different value of C and different value of gamma. Can you see that? I want to try different value of C and gamma to ask this model to select which value is the best. So for you to do that, you select a dictionary with this, this is a dictionary. And now here, because I'm selecting 2 items, C and gamma, that is why I now separate them with comma and now put the gamma and the value of the gamma in also in a dictionary. So this is called parameter grid. So you need to use this called parameter grid. Now, for us to use grid search CV, so this is how it is done. Now you can see from model selection, we import grid search CV. Now remember, this is how we do our pipeline. You create your transformation function, and now you put the algorithm, which one is SBC. And now this is also random state is one. If you look at this random state, you can see there is random state. Can you see that? It's hyperparameter. So random state is like, so you can come over here and see what is random state. It is supposed to be an integer, control the pseudo random number generation. So for example, if I put 1 here, when I run this model, the same parameters, when I run it again, I will have the same result. But if you don't put any random number, meaning if you run this algorithm, maybe you get another number, next one you get another number because of randomness. So it's a good idea to always put a random set so that you'll have consistent results. So maybe from your own end, if you share this notebook, you may have different answer. So that's the idea. Now you can see here now, I have my pipeline. Now I want to use I want to create parameter grid. So this is what I was telling. So for you to use grid search CV, you need to create parameter grid. So I create parameter grid here. Can you see that? And now I say, okay, support vector C. Now, what are the range of values? So these are the range of values I want it to use. This one. I just put it as a variable here. And now, what kernel am I going to use this one? I'm going to use linear kernel, because if you look at this one here, we have different kernel. You can see kernel by default is RBF, but you can have different kind of kernel. Can you see linear, poly, RBF? So there are many ways you can choose. Can you see that? So I want to try to. So I said at this instance, you can see this is a dictionary. Use this value of C. These are the values, and use this kernel linear. I say, okay, I finish. I want to try another one. I want to use the same as SBC, but with different kernel. Kernel is RBF. And here you can see RBF has a parameter called gamma, which I provide it is range. So if you look at this one here, when you select RBF, you have a parameter called gamma. Can you see that? So you need to provide the value of the gamma. So this is how parameter grid works. So what this means is that when we, okay, now I specify this parameter. Now I now need to call grid search CB, which is this grid search CB. The first thing you need to provide, okay, if I call this one here, look at it, grid search CB. Can you see grid search CB? The first thing is estimator, which is the algorithm you created, estimator. You can see we created the algorithm here, right? We created, this is it, right? Pipeline, we create the algorithm here. Now you put it, the first one. Can you see estimator in the pipeline CB? What next else? You put the parameter grid. Parameter grid is this that we created. Can you see this is the parameter grid? Now I put parameter grid. And now it has scoring. What kind of scoring do you want? You want accuracy. So if you look at this one here, you can also come here and say, okay, what this grid search CB means. If we go here in scikit-learn, you can see different kind of parameters. So grid search CB. The first thing, estimator, parameter grid, scoring. So you can see what is estimator. It explains this assumed to implement the scikit-learn estimator interface, which we show. The second is parameter grid, dictionary or list of dictionaries. Can you see that? Dictionary or list of dictionary. What does this mean? So you can see here, this is a list of dictionary, because if you have two things, I want to try two algorithms with different. So, but if I want to use only the first one, it can just be like a dictionary. So there's something like this. Can you see that? Just like this is a dictionary. I'm just testing SVC with this parameter, and which canal it's going to use is linear. But if I want to use different kind of settings, you need to put it in a list. So you can see, because I have two dictionary inside a list. So this is why. So you can see parameter dictionary or list, and scoring. Strategy to evaluate the performance of cross-validation. So the scoring that you want to use, the strategy we said we want to use accuracy. And if you go back here, end jobs, how many CPU you want to use. Repeat, what is repeat? If you come here, you can see repeat and estimate using best found parameter in the whole data set. So what this means is that if it finds the best settings here, it will train the machine learning algorithm with the training data set. And it uses also CB, cross validation. Grid search CB uses CB cross validation as well. If you look at this one here, we have CV. You can see it's none. When you see none, it means by default it's not activated. But when you see some values, so you can see here repeat is true, by default is true. So you can put anything here. So that's why here a number of jobs here. Here is -1. It means use as many, the total number of things I have on my computer. You can put none. It means it just use only one. So this is grid search CB. Now you run this guy. When we run this guy, now the next thing is just we fit our training data. So here you can see this is grid search CB. I fit my training data, and now, so when you fit your training data, one thing we should know is that, okay, now with this, oh, I think this one, I need to run this from the beginning. Okay, it works. Okay, so when we train this model, remember we are trying to find which parameter is the best one. So grid search CB implement what is called best score. So here it will, if we run this guy, we can see it will give us a best score. That is the best score of your accuracy, because remember we are using accuracy, but also it can give you the best parameters. So you can see here, I'm asking this grid search CB to select the best parameter in this one. I don't know whether it uses this parameter or whether it uses this parameter. And in this one, because I give it parameter range, does it select which one point is the best one? It tested this one, it tested this one, it tested, and it selected the best one. And we can use this grid search. You must use this object that you created, and now you call this dot best param and underscore. Now, when we run this, you can see it select the SBC. It uses 100. It's the best settings, and gamma is 0.01, and canal is RBF. So you can see here, it means this is the best select. This is the best combination. Parameter range SBC, which is the regularization parameter. Which value among this one? It select. This is the 100 is the best option. Can you see we have that? We have okay, we have this one, and now parameter range gamma, which is still within this value. We give it to select from within this value. It select which one? 0.01, and the canal RBF. So you can see RBF. So this is called grid search CB. it allows you to select the best settings within your hyperparameters. Yeah, so after that, you can basically make prediction with your test set. So for example, here, you don't need to retrain your model. After these steps, you can just bring your X test and Y test and find the score prediction on this. You can see we have 97,974. Remember here, we fit it here. Can you see that? X and Y trend, we fit, we see, right? And now here we just use this to, yeah. So I know it's too much, but yes, ask question, please, if you have, before we move on.
Okay. Parameters that we give, the parameter range where we give 0, 0, 0, and what have you. See, these are arbitrary number that we just give to the model.
Yes.
It turns that 100 is the best among the parameter range. C. Is there any possibility that if someone gives a different set of parameters, then you will have a better performance than what the model give us?
Yeah, so if your value is not within this range, so for example, the Katashi say maybe somebody, so for example, somebody says say paradox on 1, his parameter is 3, is 4, is 5, is 6, 7, 8, okay, maybe 8. Okay, so 9. So maybe Sam, say we said, okay, somebody just select arbitrarily. He didn't use this. He just select these values to be his hyperparameter parameter range. Now look at it here. Our best performance here is 0.98. Let's run this one again and see. Okay, we have this. So look at it. We have 0.97. Let's look at this. So you can see best parameter in these settings. So you can see the previous one, the best parameter in these settings that we give is, you can see is linear, and it select one of them. And look at the performance, like accuracy is 0.97. Can you see that? So the idea is, when you are using like, what do you call it? This parameter, for example, this, what do you call it? Regularization parameter. What are the possible values that it can take? What are the possible values that this parameter can take? So this is something that we discussed previously, like when you give it small value, what will happen? Will it increase accuracy? When you give it a higher value, will it decrease the accuracy? This is something we discussed previously. So now let me change this one here to put like 100 here. Okay, let me run this one. Still the same thing. Let me run another one. So you see, like this is ona balu yana canja makuwa? Yeah, okay, yana canja. So yeah, so this is it. We for this, so you see, this is only support vector SBC that we have parameter C and gamma and stuff like that. We have different, each algorithm has its own set of parameters. So we need to know what kind of parameter that we know we can do that. So this is called grid search CP. Grid search CP performs slightly better than what we discussed. So yeah. Okay. Right. So one thing that we have seen here is that this is one thing that maybe answer the question is here we can see that we provide a list of numbers for our machine learning algorithm to select as parameters. But what about given some range? Like for example, I say, okay, maybe the value I have here, what can you give a range to your algorithm and say, okay, just select some range. Maybe I give it from 1 to 1,000. Select any value in between this that best perform, that you think can perform best. This is the second, exploring hyperparameters configuration more widely using randomized search. So this is something user randomized search rather than giving like a definite sequence. So you can use what is called randomized search. So you can see while grid search only explore discrete user-defined choice, it may miss good hyperparameter configuration if the search space is too scarce. So since grid search is an exhaustive search, it guarantees to find optimal parameter configuration if it is contained within the specified parameter grid. So the problem is that grid search CB is exhaustive algorithm, meaning that given this set of parameter, you give it like 10, it must select one that performs better. Koda ba shi bane best ba, it must select one. But what if you give it 10 options and the best performance baya cikin waɗannan guda goma da kai selecting, then it will just select one. So can we give it a range so that we ask a range that select the best one within this range? We just give like the starting and the end point. That is what this is saying, that search, since grid search is exhaustive search, it is guaranteed to find the optimal hyperparameter if it is contained within this. However, specified large hyperparameter make grid search very expensive. So if we give like maybe 20, 30, 40, 50, that is expensive. It will take much time. An alternative approach for sampling different hyperparameter is randomized search. So this is an alternative, which is randomized search. What this means is that you just select some distribution. So this is distribution we just select here. Yes, question? Hello? Hello? Any question? Okay. So we are talking about the grid search CB in the sense that it's constrained. But we want a situation where we just give like a range of values. We said the models should search from these range of values. Now, how can we do that? Here we got to use sci-fi daga cikin me yake ne and that's sci-fi ma yake ne? Somebody can help us. Start is from start, right? Okay, let me see like this. Okay. So this is sci-fi, a package. So I'm just importing like uniform distributions. So here I'm give like from this number to this number, the last one. So it starts from this. So when I run this parameter range, let me see. So this is uniform distribution. You can see this is an object, and it just like you can see like this infra. What do you call this? Let me see this, whether this will. I don't know if this will work. It's not iterable. Okay, so let me see something like this. Okay, right. So what I'm trying to say here is that instead for us here to give like a very distinct sequence of numbers, we can give like a kind of uniform distributions. We can say that from this number to this number, we are not given specific. Select the best number, that best hyperparameter. This is called randomized search CB. Randomized search CB is exactly the same with grid search CB. It's exactly, but it's grid search. Grid search, you just give like lists of your parameters, but randomized is you just give some stuff, but you can also give it in stuff. So here you can see we make our pipeline. We start the scalar and this SVC parameter. Here, this is my parameter range now. So here, this is from start package, SciPy, we start log uniform. You put the starting point and the last one. And now here you can see the same thing. Now we just call random search CB. We put the estimator, parameter distribution. If you look at the grid search CB, we have what we call parameter grid. Can you see parameter grid? We provide a parameter grid. But here, a random search CB, we don't have parameter grid. It's called parameter distributions because you just give distribution. So we give it like, what is the parameter distribution? Okay, what am I doing? No.
Before you move further.
Yes.
Like, since in this case, we have built both grid search CB and randomized CB, randomized search. So in case whereby you are using only randomized search, because you have assigned param distributions to be equals to, you have assigned param distribution to param grid. So if you are using only this, is it necessary for you to do this? If you are using only randomized search CB.
Is it necessary to do which one?
To assign param distributions to param grid.
Yeah, so because if you don't have this, inside randomized search, is param distribution is the one that taking all these settings, because parameter range, Shiake assign Anna. Let me show you something. So here, if you look at it, we have parameter grid, right?
Okay.
Can you see that? We have If you look at grid search CB, can you see param grid?
Yeah. As part of, yeah.
So param grid is what we put, but let's look at, if you go to grid search randomized CB, randomized CB, parameter, can you see param distributions?
I get it.
Yes. So yeah, so param distribution. So you give like a number of iterations, CB, all those stuff, and you run them. So you can see it can select, it can select the best parameter, the C, and the canal. So yeah, so this is called ways to select the best performance system. And now with this, you now have your best parameters. The best parameters are this, right? And the best score is this 97. Then since in here, so the main essence, don't forget, the main essence of this grid search is, how can I select the best parameters in my model before I go and try? So when you find the best parameters now, then you go back and now train your machine learning model. Do you understand? And do whatever, do all other. So this is fine tuning. So this is very crucial steps in machine learning, like you fine tune. We will see more of this fine tuning. But of course, this is essential. Any question before we move on? Any question? Zaradin, question?
Okay. No question.
Okay. So yeah, so that is it. Don't forget, the main essence of this chapter, as I said, is how can we select the best parameters for our model so that we can select the model and have a better performance. Yeah, and you can see this on best, and there is this for you to see the best parameters. This is it, and the best score. Now the next thing is looking at different performance evaluation metrics. Now, maybe you select the best performance, you select the best parameter, you tune your parameters. Now, what are the evaluation metrics are you going to use for your machine learning? Now, for example, you are doing classification. We have different kind of evaluation methods. We have F1 score. We have precision. We have recall. We have weighted average score. We have weighted whatsoever. We have R squared for regression. We have we have different kind of evaluation methods. But the idea is we have accuracy as well. The idea is the evaluation methods you're gonna use really depends on your problem at hand, what you are doing. It depends on the task. So if you are doing this task, so this is evaluation method that can work based on that. For classification, we usually use F1 score, especially for equality distribution classes. So any question? Any question again? Okay, so I think what we're gonna do is let me share. Okay, so this is the last part of the book, looking at different performance evaluation metrics. I will expect you to read this. We're gonna stop here today. I expect you to go and read confusion matrix, to read what is recall and precision, to go and read what is rock cap, floating receiver, operating cap, to read and for multi-class classification, what kind of what I want to say is this, just to highlight, we have different kind of stuff. We have precision, we have recall, we have whatsoever if we want to do classification. But confusion matrix is what defects a lot of information about classification. But we also have what is called precision and recall, which can be calculated from the confusion matrix. We also have floating receiver operating cap. I read this long time ago as well. Just read it. We have for multi-class, if you have multi-class problem, what are you going to do? We have what is called micro. Can you see micro? We have what is called macro. Can you see that? So they are also used in different kind of scenarios and dealing with imbalance. So also dealing with imbalance. Just read it, and we can discuss more in the next week. What I can do is I expect all of us here to read this section, because if you don't read this one, it's gonna be like you're gonna miss. And we can discuss more about it, because I had to leave soon.